Hey everyone, welcome back. This is the final in the series on porosity. Hopefully you've gotten a little bit of information, at least enough to know what answers to, what questions to ask. We here at Technodyne, we love what we do, and if you've got some questions, we may not have all the answers, but certainly we might know where to find them. So don't hesitate to give us a call and drop us a line. We love talking with people. So this is the wrap up, and what I'm going to do is what I'd like to do is at least for the three most common methods that we use in throughout the pulp and paper industry, not so much in the nonwovens industry, but looking at the Gurley densometer, looking at the Sheffield test, looking at the Benson test, and how do they relate to one another? Because it's not a matter of if you're going to get somebody coming to you and ask you a question about how these units compare to these units. It's going to be when it happens. All right. So I stated in an earlier video, there's probably no perfect measurement system that's going to work for all the grades that are developed out there today. But you're still going to be able to get some relative indication of how that structure in your product is faring. Is it opening up? Is it tightening up? That type of thing. When I talk about the perfect instrument to cover all areas, one thing comes to mind is an analogy might be in the automobile that you pick. You might be able to invest in a nice high horsepower sports car that you might be able to use and get a lot of fun in driving that. But certainly that tool is going to work fine around the city, it's going to work fine on the highway, but that tool certainly isn't going to be very useful if you're going off-road and you're going mountain climbing or something along those lines. The same thing happens if you happen to select an automobile or a truck or a SUV that is designed more for off-road travel. Certainly it's going to do a nice job there, but when you get into the city environment, you get into the highway, it's not going to be comfortable, it may be too big, it might be hard to park and things of that nature. So there's no real perfect answer to cover all the possibilities that you can come across. But again, so I'd like to compare what's, at least to give you some indication of what ranges these instruments overlap with one another, and to give you some idea of where they don't overlap. Certainly we have fielded a number of different questions over the years about, I've got these Sheffield units that I normally test under. My customer is coming to me and he's requesting, okay, what does that mean in Benson? All right, so there are formulas built into the test methods that have been developed over the years, the TAPI test methods, the ISO test methods and such. So they have developed kind of rough to give you ballpark figures, but there's probably at least throughout the whole working range of the Gurley method, the whole working range of the Sheffield method, they may not overlap that well. But to give you some indication, I put together some graphics to give you an idea, for a visual of how these look. If I compare, again, I'm looking at the Sheffield, common Sheffield test, 3/4 inch Sheffield test. How does that compare to an oil Gurley test, the standard oil Gurley test? And it's a very nonlinear function that occurs if I go looking at this graphic here. As I go lower and lower in my Sheffield unit range, I go higher and higher, of course, in my oil Gurley second range, which makes sense. The tighter the sample, the longer the number of seconds it's going to take for that oil Gurley mechanism to complete its test cycle. In the same way, if I go higher and higher in my Sheffield scale, okay, the airflow is going to be increasing. The number of seconds required to have this oil Gurley densometer go through its test cycle is going to get less and less and less. So I've got, in this area here, I've got a fairly decent resolution that we can utilize to compare one unit to another. And if I take a moment I overlay this. What I've done is just simply blown this up a little bit. So I'm not going all the way out to 400 units on the Sheffield scale, but closer to 120. And I'm not going all the way up to 1800 Gurley seconds, closer to more or less 700 or 800. And in this relationship, in this area here, we have a fairly decent, reliable relationship that we can compare Sheffield units to oil Gurley seconds. Okay? I can't compare 1800 Gurley seconds to a Sheffield unit because I'm off the scale on my Sheffield range. I can't compare 400 Sheffield units to whatever Gurley seconds that might be, because now I'm going to be off the normal scale on my oil Gurley densometer. The same thing occurs when you're starting to look at comparing the Benston scale with the oil Gurley scale. Okay? As I go higher and higher in my Benston scale, I get out to 2,000 milliliters per minute in my Benston scale. I have next to no measurement, no resolution on my oil Gurley scale. So it's very difficult to try to get some reliable information on both extremes of those scales. But what I did was I took and I blew up a certain section so that in this range I can go up maybe close to 500 units on the Benston scale and still get a pretty good resolution on the oil Gurley scale. Same thing, I can go up to 600 or 700 units on the oil Gurley scale and still get a reasonable value, some reasonable number on my Benston scale. So there's a finite range that these guys will overlap. That will give you some pretty reasonable results. There's a good chance that if one customer is using a Sheffield porosity tester for his product, maybe it's a European, maybe it's South America. Again, we don't do a lot of Benston testing here in the States other than the times when we're trying to export. But built into the Benston test, the oil Gurley test, the Sheffield test, are these formulas that you can use to give you a ballpark figure of what one might relate to the other. And then finally, when we start to look at comparing the Sheffield scale to the Benston scale, Sheffield scale and the Benston scale, I can utilize almost the entire working range of either one of those instruments. I can easily go out to 400 Sheffield units and I can still get a reasonable number in the Benston scale. Okay? My resolution is quite good almost throughout the entire working range. So if I'm comparing Benston to Sheffield, I have a pretty reasonable expectation that I'm going to get some good results. So that hopefully kind of wraps things up for you, gives you some indication of how these instruments work independently, how they relate to one another, where they don't relate to one another, and give you, again, at least a starting point to be able to find out what questions to ask, how much deeper that you need, what kind of information you need to get from your customer, what kind of information the customer might need to get from you in order to provide some language, common language that you can talk to each other and work out some of the details. So I certainly appreciate the time that you've taken to look over this video. Check out other videos that we've developed along the way for other properties of brightness and color and opacity and such. We'll have quite an array of videos that you can pick from. Hopefully you'll be able to utilize us and see us as a reliable source of information. Alrighty? Till next time. See you later.